Hello everyone. Today is the 68th day of Leetcode 75 challenge. Let's begin with the 68th question. Question 136, single number. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you are given a non-empty array of integer nums. Okay. And every element in nums appears exactly twice except for one unique element that appears only once. So basically, you're given some non-empty array. Suppose these are multiple times and this is only a single time. So this is kind of an array is given to you. And you need to find the and return this single unique number. The solution must run in O of n time and use O of one extra space, no extra data structures that grow with input size. So basically we have to solve this particular solution in O of n time complexity, and space complexity should be O of one. Basically constant, right? This is the requirement of the question. And what are the constraints given? Constraints is that num's length could be from 1 to 3 into 10 to the power 4, and num's value could be from negative of 3 into 10 to the power 4 to positive of 3 into 10 to the power 4. Each element in the array appears twice except for one element which appears only once. So this is mandate. Okay. Suppose there could not be a case that 2 comma 2 is there, 1 comma 1 is there, and you have to find a thing. No, that is not what will be given to us. There will be always one integer which appears only once. Okay. So that number we have to find. So I hope you understood the problem explanation and the constraints. Now let's move to the next slide. Now let's understand the input output explanation. If you could see in the example 1, the output is 1 because 1 appears only one time, right? And in the second scenario also, or in the second example, if you could see, output is 4 because 4 appears only one time, right? So there was nothing much to explain in this particular scenario, because by seeing visually we could just figure out how things are done, right? Okay, so let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem, and we should do it by understanding the goal first. We're given a list of integer nums. Every number appears exactly twice, except one number that appears only once. We must find and return that single number. Fine. Our goal is to find that particular single number which appears only one time. Okay, and all the other numbers will appear exactly twice. So the what could be the brute force solution? The brute force solution could be using a dictionary in Python or using a map, right? We don't have a map concept in Python directly, so we will be using dictionary. And in that, what we could do is that we could run a for loop in the array, okay, and we can store it as key value pairs, key value, right? Suppose if we are given 2 comma 2, 1 comma 1, 3, and 4 comma 4, right? So if you iterate this array from 0 to n, 2 count is 2 times, 1 count is 2 times, 3 count is 1 time, 4 count is twice, 2 times, right? So we could store the count or frequency of each integer in the dictionary, and then we can check in the dictionary that whose value is only 1, right? So, and whosever value is 1, we will return its key, which is 3, right? So that will take O of n time complexity, which is fine, but it will also take O of n space complexity, right? And if you remember, it was pointed out that the space complexity should be constant, not O of n, right? So you could tell the interviewer this particular solution, but then you have to jump to the one which uses only O of one extra space, which basically constant space. So we need to do a mathematical or bitwise trick in that particular scenario, because this question belongs to a bit manipulation concept. Okay, so let's visualize this process. And before that, let me take an example. Suppose 4 comma 4 comma 2 comma 2 comma 1. Okay, great. Now here I have written that we can start by using XOR operation to solve this problem. Okay, why I will tell you later. Now let's understand the properties of XOR. XOR of a number with itself is always a 0. Suppose it is a property of XOR, right? You don't have to put your mind why it is 0. Just it's a property of XOR. So 4 XOR 4 will give me 0. Or basically you could say A XOR A will give me 0. And if it is 4 XOR 3, it will give me XOR of a number with 0 is always the number itself, right? Let me write that also. 4 XOR 0 will give me 4. Or you could say A XOR 0 will give me A. And also other properties of XORs could be, this is the main property. If it is X, suppose X XOR Y is equals to Y XOR X. Okay, this is a cumulative scene. I could write C for cumulative, and there is associative also, which basically says that if X is done XOR with Y, then that completely is done XOR with Z. It gives us X XOR with Y XOR Z or Z, right? These are same. So these are the four properties of XOR which we could take in consideration. Okay, and to understand it better, we could also do it this way. Suppose 0 XOR 0 is 0. Okay, 1 XOR 1 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. Okay, in binary representation it is done this way. So I hope the properties of XOR is clear to you now. Let's take this example, right? So now if we XOR all the numbers in the array, every pair of identical numbers will cancel out to 0. The only number left after all the cancellations will be the one that appears once. Okay, so suppose if I'm doing XOR 7 XOR 3 XOR 5 XOR 3 XOR 7. Okay, so this will result in 5. Now why? If you remember, I earlier explained cumulative property, right? Which basically states that A XOR B is similar to B XOR A. Okay, this is cumulative. I will write it as this way. Again, associative property, if you remember, A XOR B XOR C is similar to A XOR B XOR C. Fine, this is associative. ASS. Okay, let's keep it aside. Now, let's take an example to understand. Suppose I'm taking A XOR B XOR A. Fine. Now, using associative and cumulative properties here, A XOR A XOR B, right? I have I've did the same thing, right? Now we know that, and so we know that if the same XOR of a number with itself is always a 0, right? This property. So this will tend to give us 0 XOR B, correct? And XOR of a number with 0 is always a number itself. A XOR 0 gives us A. So in that scenario, if you would see 0 XOR B will give me B. Fine. I hope you understood this, because A XOR B and B XOR A is same using cumulative and associative property. Using associative property, what I did that I brought down A XOR A together, which was totally XORed with B. Fine. So I hope you understood this explanation. So now let's apply that particular scenario here. Okay, what will happen in the backend is that 7 XOR 7 will come together, XOR with 3 XOR 3, XOR with 5. Fine. This will give me 0. This will give me 0, right? So 0 XOR 0 XOR 5 will result in 5. So this is the only single number which appears only once in the complete given array. Okay. So you could think XOR as a duplicate eraser. Since duplicate vanish and XOR does not depend on the order cumulative and associative, depends on the order cumulative and associative, only the single unique number survives after processing the whole array. Right? I gave you the backend and the theory of how the XOR works and how we get the output of the number which only appears single time in the complete given array. Now, how we can simulate this? We will start with a variable, suppose XOR equals to 0, right? And we will iterate over the complete nums for val in nums, something like that, right? And we will keep on doing XOR equals to XOR of val, right? And at the end, we will be having the value in the XOR variable. And this particular long term could also be written in the way XOR val, XOR val, right? Similar to this. So what we figured out? We figured out that XOR acts like a perfect duplicate eraser. Numbers that appear twice vanish, leaving only the unpaired number, or when the number with the count 1. If both elegant, it's both elegant and efficient, directly exploiting bitwise properties instead of using extra data structures. Right? So I hope you understood the intuition explanation. It was pretty easy and straightforward, I hope. So let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach how we're gonna solve it. So first step will be initializing the variable. We will take this variable XOR and initialize it with 0. This will store the running XOR result as we process each number in the array. Now we will loop through each element well in nums like this for well in nums. Okay, and we will update XOR as well. Okay. At step 3, processing all the numbers using XOR. After processing the entire array, XOR will hold a single number that does not have a duplicate. So after that, we will return XOR. Okay, and we will initialize XOR here as 0. Fine. You might be having the doubt why we are initializing XOR with 0 initially, right? Suppose we know that 0 XOR B will give me B, right? So when I iterate the array, suppose 2, 3, 3, 2, 1, right? And when I do XOR with 2, it is basically, if I open this particular thing, it will be XOR this way, right? So the XOR variable will be storing 2 then. Got it? This is how, that is why we are putting XOR equals to 0 initially. So I hope you understood the approach explanation. Now let's move to the next slide. The code is the exact copy of the approach we discussed. Let's understand it line by line. So if you could see, this is the main function which is given to us. We initialize XOR with 0. We iterate the complete nums and we return the XOR, which basically contains the final result. And we can clearly see the time complexity for this is O of n because we iterate the complete array of size n, right? And the space complexity is O of 1 because we are not using any extra data structures such as array or dictionary or list anything to store the value. Okay. So I hope you understood the code explanation also. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. And for our better understanding, I have also brought down the code here. Okay, let me create this array here. Fine. Let the XOR variable be 0, and let me open this particular thing and write it properly. XOR equals to XOR with well. Fine. Great. So right now XOR value is 0, right? So 0 with 4 will give me what? It will give me 4 definitely, right? So 4. Now we came to 1. 4 was done. Now we are in 1, right? So now XOR value is 1. 1 XOR with 4. Let's do the XOR of those. 4 is represented at this way and 1 is represented as this way. So it will give me 1, 0, 1. And 1, 0, 1 is what? 4, 2, 1. It's 5, right? So the XOR value is 5 now. Great. Now it will come to this part and we will be having 5 XOR with 2. Let's do the XOR of 5 and 2. 1. Okay, so 5 is represented as this way and 2 is represented as this way. Fine. If I do the XOR, I will get triple 1. Triple 1 means 7, right? Now XOR will have 7 and we will move ahead to 1. Now we have 7 XOR with 1. 0, 4, 5, 7 XOR with 1, right? So 0, 0, 0, then 1. So 0, it will give me 1, 1, right? So what I have now, I have 6 with me, correct? So after that, again, we will do the XOR. 6 XOR will be done with 2, right? How 6 is represented? 6 is represented as this way, and 2 is represented as this way, if I am not wrong. Yeah. So 0, 0, 0, similar numbers, 0. This is XOR property. Okay. If you remember, XOR A will always give 0, right? That's why. And 1, 0 is 1 and 0, 0 is 0, right? So this gives me 4, if I'm not wrong. Yeah. So our XOR value is 4. So it will return 4 at the end and our output is also 4. So I hope you understood how we did the dry run here. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach and the code, and also the properties of XOR as I explained earlier. And after that, do a dry run by yourself on 2-3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now since you're familiar with the problem and the solution, let's move to the lead code and code the solution. So we will start by initializing the XOR variable XOR equals to 0 for, then we will iterate the given nums. For val in nums, then we will do the XOR, the val, and that's all, and we will return XOR. Now let's try submitting for the sample test cases. Now let's finally submit our solution. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.